you all for joining today's webinar on confined space and construction. This webinar is offered to you in part by the USF 21D Consultation Program, the USF OSHA Training Institute Education Center, and the Sunshine ERC. This presentation is not a standard or regulation, and it creates no new legal obligations. It contains recommendations as well as descriptions of mandatory safety and health standards. The recommendations are advisory in nature, informational in content, and are intended to assist employers in providing a safe and healthful workplace. The Occupational Safety and Health Act requires employers to comply with safety and health standards and regulations promulgated by OSHA or by a state with an OSHA-approved state plan. In addition, the Act's General Duty Clause, Section 5A1, requires employers to provide their employees with a workplace free from recognized hazards likely to cause death or serious physical harm. The webinar will be 1.5 hours in length. We will reserve approximately 15 minutes at the end of the webinar to answer questions. You may experience some delays during the presentation as we transition between speakers. A few ground rules before we begin. You have been entered in listen-only mode. Please enter your questions as they arise into the questions box. All questions will be answered at the conclusion of the presentation. If you should experience any technical difficulties during the presentation, please contact your department's IT help desk. A copy of today's PowerPoint will be sent to the email address you entered at the time of registration within 5 business days. Finally, a survey will be distributed towards the end of the webinar. It will take 2 minutes to complete. Your feedback is very important to us. This allows us to continue to offer quality webinars that are beneficial to you. My name is Thalia Barber, and I am the Marketing and Communications Officer for the USF Safety Florida Consultation Program, and I will serve as your moderator this morning. Today's panel of experts consists of Gabe Garcia. Based in Miami, Gabe Garcia serves as a USF Safety Florida Safety and Health Supervisor and Consultant to employers in South Florida. Mr. Garcia performs site inspections focused on OSHA standards and best practices for workplace safety and health management systems. He develops and conducts programmatic training and evaluates safety and health program management activities for small, privately owned companies. Next is Luis Silva. Luis M. Silva has dedicated his career to the field of occupational safety and health for over 24 years, with combined experience in occupational safety and health regulatory compliance, industrial hygiene, and program management for both compliance and consultation. Mr. Silva sincerely believes one of the fundamental principles of an effective safety and health system is participation of both management and workers to create a team environment and make safety and health part of their daily working lives. Without further ado, I now turn the webinar over to Dr. Brian Warwick, the USF Safety Florida Consultation Program Director.
Thank you, Thalia, and good morning to everyone. First, I'd like to take this opportunity to thank our distinguished panel, Gabe Garcia and Luis Silva, for taking the time to share their knowledge and their expertise. I think the audience will be well served by your selection. Over 2.1 million workers enter permit-required confined spaces annually. Unfortunately, this has resulted in multiple fatalities. What makes this hazard so unique is its deceptive nature. It looks and feels safe until you enter. In 2018, NIOSH reported that approximately 60% of confined space fatalities were rescuers. OSHA repeated this claim that most of the confined space entry fatalities were multiple fatalities involving would-be rescuers. We've also learned from these accident reviews that written procedures and training by themselves don't work unless we execute a viable confined space permit process. If not, we run the risk of doubling our fatalities like we did in 2012, 2017. Before we begin, however, I'd like to take a minute or two to showcase and discuss some of our sponsors for this webinar. For those of you who may not be aware of our services, the USF Safety Florida Consultation Program is the state's official safety and health program administrator. Not to be confused with OSHA enforcement, where citations are issued or penalties proposed. The consultation program primary mission is to assist Florida small business comply with OSHA standards, thereby eliminating workplace hazards that can potentially cause injury, illness, or death. Essentially, we help employers maintain a safe working environment. Our services are free and confidential, and while working with us, you can actually defer a planned OSHA inspection. You know, while some may argue that the guiding principle of business economics is the maximization of profit, others would insist that is the avoidance of loss that should be the focus. These losses come in the form of inefficiencies, waste, and in our case, direct and indirect accident and injury claims. As a result, employers remain profitable through cost avoidance in injuries, illness, reduce workers' compensation costs, avoid OSHA penalties, and increase productivity. All of these realized from a safe working environment. Next slide. Our team has more than 150 years of combined occupational health and safety leadership experience in construction, maritime, manufacturing, and agricultural operations, and a position in each region of the state. Our focus is on small employers with high hazard operations to help not only identify hazards, but work with the client in producing viable solutions. As we look to building sustainable systems, our team is focused on helping employers develop customized health and safety management systems where their program is continuously being reviewed, revamped, and renewed following a quality methodology. Our online tool, known as the Safety Rider, is second to none. It provides the employer the ability to produce their own site-specific health and safety plan based on their industry or specific hazard. The plan could be stored online for easy retrieval and update or file as a paper document on site. We also offer a multitude of free DVD and online video streaming on a vast array of safety and health topics to include confined spaces and even the current COVID crisis. Some of the training are delivered in both Spanish and even Creole. We ask that you take the time to visit us at safetyflorida.com as we endeavor to make Florida the safest place to work. I'd also like to mention the USF OSHA Training Institute Education Center, DOTI for short. Based right here in Wesley Chapel, they can deliver expert training primarily in the southeastern United States. They offer outreach training program, trainer courses, and occupational safety and health standard courses in the general industry, maritime, construction, and disaster site worker training. And along the same lines, they offer technical courses and a number of these other courses. The permit required confined space is one of those technical courses as well. They can be reached at usfotiec.org or phone number 813-994-1195. So without further ado, I now turn over the presentation to Gabe Garcia, who will talk a little bit more on this permit process. Gabe?
Well, thank you, Dr. Ward, and good morning, everyone. My name is Gabe Garcia, and this presentation today we're going to cover the following items in here. Keep in mind that this will be strictly for construction, and this will be covered under subpart AA 1926-1201. In this presentation, I'm going to cover the definitions, some of the samples, and the permit required. The biggest differences between general industry and construction. We're going to go over the written program. We're going to talk about controlling the hazards entry equipment, detection, permits, and the contact employers, employees, training, assigned duties, and rescue personnel. But before we go any further, I want to make sure everybody understands that confined space entry is a very complex and hazardous task. Unfortunately, we will not be able to cover all aspects of this program in 1 hour. So hopefully this will just give you an oversight, an overview, a guide, and guide you in the right direction. As Dr. Work mentioned before, the USF OTI Ed Center will be offering the OSHA 2264 on April 12th through the 14th of 2021. Now let's cover what is a confined space. The definition of confined space is a large enough area for an employee to work and enter fully and perform assigned work. It is not designed for continuous occupancy by the employee and has limited or restricted means of entry or exit. Now, you have a picture that you're looking at, and I want everybody we're going to put a poll up and take about 30 seconds to identify this picture and see if this is considered a confined space in construction based on its definition. It is considered a large a confined space, and let's take a look at why. As you can tell, the area is large enough for an employee to work and enter and fully perform their assigned work. It is not designed, obviously, for occupancy by the employee, and it has limited or restricted means of entry or exit. However, although this is a very common sight on a construction site, it is covered under subpart P, CFR 1926-650 under excavations. So it would not be covered under the confined space program. Here, you're going to see some of the samples that you may encounter in a construction site. Manhole is usually one of the most abundant, but manhole can consist of water, sewer, or storm drains. May have electrical, communications, and or other utilities. Concrete piers, columns, heating, ventilation, and air conditioning, HVAC ducts, precast concrete, and other preformed manhole units, drilled shafts, lift stations, etc. Now that we talked about the confined space, let's talk a little bit more about the permit required confined space. Pretty much it has to have all the requirements of the confined space and has to have one or more of these characteristics. It must contain or has the potential to contain a hazardous atmosphere, contains a material with the potential to engulf someone who enters the space, has an internal configuration that might cause an entrance to be trapped or asphyxiated by inwardly converging walls or a by floor that slopes down and tapers towards smaller cross sections, and or contains any other recognized serious safety health hazard. The ones above the walls converging down, you're going to see that picture on the right hand side there. And even though that's typically not seen very much at a construction site, but they may be some potential utility piping that can follow that same principle. Now let's take a look at the biggest differences between general industry and construction. General industry, as I mentioned, subpart J 1910-146 will include everything plus a competent person must conduct worksite evaluations and identify all permits and non-permits spaces prior to entering. Employing using alternate procedures for permit and space entry must prevent physical hazard exposures through the elimination or isolation through methods such as lockout, tagout, forced air, etc. Permits may be suspended instead of canceled, provided that the space is returned to the permit conditions prior to entry. And in addition to entry, continuous monitoring of atmospheric and engulfment hazards must be conducted throughout the process. Employees relying on local emergency services for rescue must ensure responders are notified in advance, and you must find out if the responders will be able to respond or they will be unable. Specific information exchanges requirements for multi-worksite employees, such as the host, the GC, and the subs must share constant information about the process. All right, now that we know about confined space and permit required confined space, we need to put it all together, and here's where it begins: written programs. Any employer who allows employees entry into a permit space must develop and implement a written program for safe space. This plan must implement necessary measures to prevent unauthorized entry. It must identify and evaluate permit space hazards before allowing employees entry. It must test atmospheric conditions in the permit space before entry operations and monitor the space during the entry. Perform appropriate testing for the following atmospheric hazards in this sequence: oxygen first, combustible gases or vapors, and toxic gases and or vapors. It must be included in the written programs. You must identify and implement the means, procedures, and practice to eliminate or control hazards necessary for safe permit space entry operations. You must describe all the employee job duty titles, such as the authorized entrant, the attendant, and the supervisor. Must provide and maintain at no cost to the employee PPE and any other equipment necessary for safe entry and require employees to use it. Ensure that at least one attendant is stationed outside the permit space for the entire duration of the operation. Coordinate entry operations when employees of one or more employer are working in the same permit space. Identify appropriate procedures for summoning rescue and emergency services and preventing unauthorized personnel from attempting rescue. Establish in writing and implement a system for preparation, issue, use, and cancellation of entry permits. Review established entry operations annually and revise a permit space entry program as necessary. And implement procedures that any attendant who is required to monitor multiple spaces will follow during an emergency in one or more of those spaces. Now we take care of the administration. Let's identify the controlling hazards. The employee's written program should establish the means, procedures, and practices to eliminate or control hazards necessary for the safe permit space entry operations. These may include specifying acceptable entry conditions, isolation of the permit space, providing barriers, verifying acceptable entry conditions, and purging, making inert, flushing, or ventilating this space. Some of the equipment to be used in addition to PPE, the employee must be required for safe entry into a permit space should include testing equipment, monitoring, ventilation, communications, and lighting equipment, barriers and shields to prevent people from coming in and protect the entrance, ladders to go up and down inside, and last but not least, retrieval devices. Detection of hazardous conditions. If a hazard conditions is detected during an entry, employees must immediately leave the space. The employer must then evaluate the space to determine the cause of the hazardous atmosphere and modify the program as necessary. When entry to the permit space is prohibited, the employer must take effective measures to prevent unauthorized entry. Non-permit confined spaces must be evaluated when changes occur in their use or configuration, and when appropriate, they must be reclassified as a permit space. So what this is telling you is that even though a confined space may not be a permit required, however, if it has the necessary potential for hazards in it, it must be then reclassified as a permit space. And by the same token, a space with no potential hazards to have the atmospheric hazards may be classified as a non-permit space only when all the hazards are eliminated in accordance with the standard. If entry is required to eliminate hazards and obtain data, the employee must follow specific procedures in the standard. Contract employers. Host employers must inform any contractors whom they hire to enter permit spaces about the following: the permit space and permit space entry requirements, any identified hazards, the employee's experience with the space, such as knowledge of the hazardous conditions and or precautions or procedures to be followed when in or near a permit space. When employees of one or more are conducting entries operations, the affected employees must coordinate entry operations to ensure that the affected employees are properly protected from permit space hazards. The employer also must give contractors and any other pertinent information regarding hazardous and operations in the permit space and be debriefed at the conclusion of the entry operations. Permits. Entry permits must be signed by the entry supervisor, must be posted at the entrances or otherwise made available to the entrance before they enter the space. The permit must verify the pre-entry operations outlined in the standards 1926-1206 have been completed. The duration of the entry permits must not exceed the time required to complete an assignment. Supervisors must cancel entry in permits when an assignment is not completed or when a new condition exists. New conditions must be noted on the canceled permit and used in revising the permit space program. The standard requirement that employers keep and all canceled permits for at least 1 year. And one of the biggest differences between general industry and construction is, in this case, that permits can be suspended instead of canceled, provided that the space is returned to permit conditions prior to re-entry. Worker training is critical. Before the initial work assignment begins, the employer must provide proper training to all workers who are required to work in the permit space. After the training, employers must ensure that the employees have acquired the understanding, knowledge, skills to safely perform their duties So a 5-minute toolbox or just talking one way is really not going to cut it. You need feedback, you need cooperation, and you need guidance between the trainer and the student. Additional requirement, additional training is required when the job duty changes, obviously. The changes occur in the permit space program or the permit space operation presents a new hazard and employee's job performance shows deficiency. In addition to the training, rescue members also require trainings in CPR and first aid. Employees must certify that this training has been provided and documented. After completion of the training, the employer must keep a record of all the employee training and make it available for the inspections by the employees and their authorized representative. The records must include the employee's name, the trainer's signature, initial and dates of training at a minimum. Here are the assigned duties, and we're going to start off with the authorized entrant. They are required to know the space hazards, including information of the means of exposure, such as inhalation or dermal absorption, signs of symptoms and consequences of the exposure. Use appropriate personnel protective equipment properly and maintain communications with the attendants as necessary to enable them to monitor the entrance status and alert the entrance to evacuate when necessary. They must exit the permit space as soon as possible when ordered by an authorized person. He or she recognizes the warning signs or symptoms of an exposure, a prohibited condition exists, or an automatic alarm is activated. Alert the attendants when prohibited conditions exist or when warning signs or symptoms of exposures exist. The assigned duty of an entry supervisor. Supervisors must know the space hazards, including information on the mode of exposure, the signs or symptoms, and consequences of exposure. Verify emergency plans and specify entry conditions such as permits, tests, procedures, and equipment before allowing entry. Terminate entry and cancel permit when entry operations are completed or if there's a new condition exists. Verify that rescue services are available and the means for summoning them are operable. Take appropriate measures to remove unauthorized entrance and ensure that entry operations remain consistent with the entry permit and that acceptable entry conditions are maintained. The rescue personnel, employees must ensure that the responders are capable of responding to an emergency in a timely manner. Employees must provide rescue personnel with personal protection equipment and including respirators and training how to use it. Rescue services personnel must also receive the authorized entrance training and be trained to perform assigned duties. Now, one of the things that we need to clarify is that, once again, if you were live close by to a EMS system of responders, that's fine. You may be able to include that in your written program. However, if you are 30 minutes away from the nearest ambulance, then you might have to consider a team, rescue personnel team on site. All rescue must be trained in first aid and CPR at a minimum. One rescue team members must be current certified in first aid and CPR. Employers must ensure that practice rescue exercises are performed yearly and that rescue services are provided access to permit space so they can practice the rescue operations. Rescuers also must be informed of the hazards of the permit space. Some of the equipments used are harnesses and retrieval lines in order to conduct rescue. Authorized entrants who enter a space must wear a chest or a full body harnesses with a retrieval line attached to the center of their backs near their shoulder level or above their heads. Wristlers, as you can see in the pictures on the upper right-hand corner, may be used if the employer can demonstrate that the use of a chest or full body harnesses is not feasible or it can create a greater hazard. Also, the employer must ensure that the other end of the retrieval line is attached to a mechanical device or a fixed point outside the permit space. This mechanical device must be able to retrieve somebody from a vertical type permit space more than 5 feet deep, such as the picture below on the right. In the event an injured entrant is exposed to a toxic chemical substance for which a safety data sheet is available or similar information is required to be kept at the worksite, the safety data sheet or the other written information must be made available to the medical facility personnel treating the exposed entrants. And with this, I'm going to turn it over to Luis Silva. He's going to cover the hazards that you may encounter and also some of the testing and go a little bit more detail on some of these procedures.
Thank you, Gabe, and good morning, everyone, and welcome. In this part of the webinar, we will cover hazards that you may encounter when working in confined spaces. We'd like to point out this is only a general overview of some of the most common hazards in confined spaces. The purpose of this presentation is to increase your awareness and bring to your attention some important points and questions you need to answer as part of your planning and preparation when dealing with confined space entry. So we learned in the presentation already that what is a confined space according to the OSHA definition? Well, it's a space that is large enough to enter and do work. It has limited or restricted means of entry or exit, and is not designed for continuous occupancy. We also learned in this presentation that hazards in confined spaces are fatal. And like Dr. Warwick mentioned, it's about 22.1 million workers enter confined spaces annually. 61% of those is in construction, and 85% of those fatalities, the supervisor has been present, and 29% of those fatalities has been supervisors. There's some other interesting statistics about confined spaces. If you want to learn more, and you can visit the Bureau of Labor Statistics website and look at this data. One thing that I just want to point out, if you look at the right-hand side of the table, the two major causes of fatalities are engulfment and inhalation of harmful substances. So in other words, the number one cause of fatalities in confined space is actually asphyxiation. So let's look at some of these fatality cases. I want to point out in this section that only 31% of the employers involved in these cases had a written program. None of them had written procedures for the confined space that they entered. 15%, only 15% had training, and none of them had a rescue plan. So let's look at some of the hazards in confined spaces. We have deficiency of oxygen, not enough oxygen, and we're going to talk about this a little bit later. We have too much oxygen when it's enriched atmospheres. We have flammable atmospheres. We can have toxic atmospheres. They have toxic substances in them. We can have temperature extremes, engulfment hazards, noise, wet surfaces, falling objects, biological, snakes, spiders, organic waste, physical configuration of the space. That is considered a hazard because it's going to limit your ability to enter or self-rescue inside of a confined space. And of course, you have safety hazards, electrical faults, power tools, and so on. So what is a hazardous atmosphere? According to OSHA, CFR 1926-1202, a hazardous atmosphere is one that can expose employees to death, incapacitation, and impairment of ability to self-rescue. This is important in confined space. Can also cause injury, acute illness, for one of the following causes that we will mention. Oxygen deficiency inside of the space. That's when your oxygen concentration is below 19.5%. Remember these numbers, 19.5%. Too much oxygen is when the oxygen levels are more than 23.5%. Flammable atmospheres is when you're exceeding 10% of the lower flammable limit or the lower explosive limit. And of course, you can have also airborne combustible dust exceeding the LEL or the LFL. So, let's look at air. What do we have in air? Air is about, we're going to round these numbers, it's about 78% nitrogen, 21% oxygen, and 1% of other gases like carbon dioxide, argon, and water vapor. So what happens when we have an oxygen deficient atmosphere? It's when, like we say, below 19.5% oxygen. So what happened? What are the health effects? What happened to your body? Notice that between 10 and 12%, you start losing physical ability, and between 9 and 10%, there is also mental failure. So just because if you look up in between 15 and 19, it's already taking you to an impairment state in which you won't be able to exit the confined space because of the hazardous condition. And of course, 8 minutes is fatal. So those are the health effects of deficiency of oxygen. So deficient is below 19.5% of oxygen. And, let's ask ourselves, is actually 19.5% of oxygen really safe? We know that the oxygen is about 21% in air, 78% of nitrogen. So let's look at what OSHA says. OSHA defines the hazardous atmosphere if the oxygen is below 19.5%. But the standard does not say that the atmosphere containing 19.5% is safe. So levels below may be hazardous because of the physical impairment, like poor judgment, mental failure, fainting, vomiting, and so on and so forth. But there's other factors to consider. So what happens when there is less than 20.9% oxygen, or 21, we were rounding it up, less than 20.9. Well, like we saw already, the air is about 78% nitrogen and about 21% oxygen. So this is a ratio of about 4 to 1, four times the nitrogen, 1 time the oxygen. So if for every 1% change in the oxygen level, there's going to be a 4% change in nitrogen because both gases are displaced at the same rate in the confined space. So what happens when there is less than 20.9% oxygen? We need to ask ourselves, what else is in the air. There is something displacing the oxygen. And we learned that oxygen and nitrogen is 4-to-1. So if there is whatever is displacing the oxygen is going to displace also the nitrogen. So if the oxygen drops 1.4% from 20.9 to 19.5, that level that we were talking about, so the nitrogen is also going to be dropping 4 times that, is 5.6%. So actually, we have a total of 7% drop between oxygen and nitrogen, which we can breathe. And we know that 1% is about 10,000 parts per million. So we have 70,000 parts per million or something else in the air that is displacing the oxygen and the nitrogen. So what else is in the air? So in most of gases and vapors, the permissible exposure limit, it goes between 10 to 100 parts per million. So 10,000 parts per million is about 100 times of the permissible exposure limit for most gases and vapors. So 19.5% oxygen is a value that's been established only because of the physiological effects. We need to be very careful. If you have less than 20.9% oxygen in the space, you have to ask yourself why. And if you cannot get an answer, you do not enter the space until you get the answer or until you have established that the oxygen is back to 20.9. Now let's talk about when there is too much oxygen in the atmosphere. It's more than 23.5% oxygen. So what happens is this is going to cause flammable and combustible materials to burn or explode faster than normal. So hair, clothing, any materials that you're working with that are flammable. If you have oil in your gloves, if you have oil or grease on your clothing, and this is flammable, well, if you have more than 23.5% oxygen in the space, it's going to be more, it's going to increase the flammability of all these materials. It's important to remember that never to use pure oxygen to ventilate. There has been fatalities of people doing this. So never use oxygen, and never store or place compressed tanks or gases inside of a confined space. So let's look at flammable atmospheres. As we know, and we already talked about, well, the oxygen content in the air is really critical if it's more than 23.5%. There might be also the presence of a flammable gas, a vapor, or the presence of dust. So that there's a certain mixture of gas and air, depending on the concentration of oxygen, that can lead to an explosion. And you have typical ignition sources, your electric tools, sparking, welding, cutting operations, smoking, believe it or not. So flammability levels, we've been talking about LEL and LFL, which are synonymous: lower explosive limit, lower flammable limit, and you have the upper explosive limit and the upper flammable limit. What's the OSHA definition? OSHA says that the LEL, lower flammable limit or lower explosive limit, means the minimum concentration of a substance, gas, vapor, mist in the air that needed for an ignition source to cause a flame or explosion. What is the UEL? Is the maximum concentration of a substance in air in which an ignition source does not cause a flame or explosion. So that's why there is that mixture of air and gas that is going to be optimum for fire or explosion. And that's why the limit is 10%. So if it's too little gas, it's going to be too lean, it's not going to blow, it's not going to burn, or it's going to be too rich and then it's not going to burn, it's not going to blow. So that's why OSHA considers a space to have a hazardous atmosphere when the lower explosive limit, the LEL, exceeds 10%. Let's look at toxic atmospheres. Well, it can be created by things that you're storing, products, gases that you store in the confined space. Gases that may be released during cleaning the materials in the confined space, decomposition of materials in the confined space, like organic material, or the work that you're doing, welding, painting, sealing, bonding, using chemicals. And also, you have to consider areas adjacent to the confined space. You might have toxic gases or toxic substances migrating from one space to another. So you have to also consider that. So let's look at some of the most common toxic gases that we find in confined spaces. Well, oxygen, we learned that if it's below 19.5, it's no good. If it's more than 23.5, it's not good either. It can accelerate fire and explosions. Methane is an asphyxiant. Why? Because it's going to be displacing the oxygen. You have hydrogen sulfide. You have carbon monoxide, nitrogen, ammonia, acetylene, carbon dioxide, chlorine, and much, much more. So what happens with these gases inside of a confined space? Well, the gases are going to, depending on their weight, they're going to be either accumulating in the bottom of the confined space, or they're going to rise to the top of the confined space. Some of them are going to drift right in the center along there, and some of them can cause pockets in certain areas of the confined space. But why is this? Well, there's some gases that are lighter or heavier than air. So if you're looking at this, nitrogen, it's about really close to air. So it's going to stay around there in the center of the confined space, more or less. But if you look at methane, it's a lot lighter than air. So it's going to rise to the top of the confined space. But if you're looking at, for instance, carbon dioxide or gasoline vapors, especially the gasoline vapors, they're going to be towards the bottom of the confined space. And this is important to know. Temperature extremes. Your confined space is another consideration when you're doing the assessment of your confined space. You need to look at what's going to be the temperature inside of the confined space, and how the work that you're doing, the personal protective equipment that the workers are wearing, the humidity factors, and everything else that you're going to do, how that is going to be affecting the temperature. There is a very good website, and there is the address for it in the OSHA website for heat stress prevention resources. I recommend you to visit that website, and there's a lot of great valuable information there. So let's look at engulfment or flooding. Next, this can happen with granular loose materials like grain stored in bins, in hoppers, sand, and also flooding of confined spaces, like in water or sewage type of confined spaces. So these things also are hazards in confined space. So for engulfment hazards, the CFR 1926 requires that you do continuous monitoring for these engulfment hazards, and you have to be capable of alerting, to have an alert with sufficient time to allow safe exit of the confined space. And those alerts can be remote sensors, lockout, and also communication equipment. Safety hazards. You have noise. Remember, the noise is going to be amplified inside of these smaller confined space because of the acoustics inside of the space. You have wet surfaces, slip and falls, falling objects. You have also falls just entering or exiting the confined space, electrical, power tools, mechanical, pressure. And also you have biological hazards. you know, especially here in the state of Florida, you can find gators, you can find snakes, spiders, or, you know, biological hazards by the decomposition of human waste and the human waste itself inside of sewer systems. So all these are important considerations that need to be made. Also, we have the physical configuration of the space. This is going to be, as you can see in the picture, is going to make more difficult not only the entry, but also the egress or the rescue of a worker. This is a very important consideration. And also, if you remember what we were talking about, the behavior of the gases, how they move up or down or just drift in the middle. So the configuration of the space is going to be, it's a very important consideration when you're testing the atmosphere inside of the confined space. So the CFR, the Code of Federal Regulation, in that section 1203, it says, like we mentioned before an employee enters the space, the internal atmosphere must be tested with a calibrated direct reading instrument for oxygen content, flammable gases and vapors, and for potential toxic air contaminants. And the CFR, the rule is very clear. It says in that order. Why? Because we learned that changes in oxygen are going to be an indicative, not only that it's not sufficient oxygen and can asphyxiate the worker, it's going to be a very good indication that something else is in the air, and also is going to affect the flammability or explosibility inside of the confined space when you have the reading of oxygen and the lower explosive limit reading. That's going to help you determine that something is wrong inside of that space. And also the CFR 1926 says that no hazardous atmosphere is permitted within the space whenever any employee is inside the space. This is really important, because what the rule is saying here is that you have to eliminate or control all hazards that we have mentioned before the worker enters the space. So this is really important. So atmospheric testing. So we look for oxygen, like the rule says. The first thing the first reading that we take is oxygen. And of course, we know that if it has to be, we're looking at no less than 19.5 and no more than 23.5. Also, we look for the LEL, the lower explosive limit. And we look at that 10% that we already talked about. Also, you have to be aware of any other contaminants that can be in the space, and know the permissible exposure limits of that potential gas or contaminant that your assessment has discovered. You have to do continuous monitoring. That's been already mentioned. You have to include your readings of your testing in your confined space entry permit. You have to test all areas. Remember what we talked about in the behavior of gases? Some are lighter, others are heavier, others close to air. So make sure that you're not only testing the entry point of the confined space. You have to know the internal configuration and take into consideration how the gases can be behaving, the potential gases inside of the space be behaving, and make sure that you test all that stratified atmospheres. So the question that always comes up is, well, do I do continuous or periodic monitoring? The CFR section 1203 says that the atmosphere within the space must be continuously monitored, unless the entry employer can demonstrate that equipment for continuous monitoring is not commercially available, which is very difficult because the market, there is a lot of good equipment out there, or periodic monitoring is sufficient, that you have to demonstrate that. So what does that mean? That if you're not using continuous monitoring, you have to be checking the atmosphere regularly to ensure that the continuous forced air ventilation, which most likely that will be your control, the way that you're controlling the atmosphere inside of the confined space, is in actuality preventing the accumulation of any gases or any hazardous atmosphere inside of the space. So you have to demonstrate that. So I would recommend always use continuous monitoring. There's a lot of monitoring devices out in the market. So it's very difficult that you won't be able to find a piece of equipment that is not going to do the job. As you can see, there are multiple gases, 2, 3, 1, 4 gases. I would never use, my personal opinion, I would never use a one gas monitor. I always would use at least what is the most common tool that is used in confined spaces, the 4-gas monitor that will check for oxygen, will check for the lower explosive limit, hydrogen sulfide, and carbon monoxide. Now, is just this monitor sufficient for me to do my required monitoring? Well, no, you need more equipment than that. Because remember, you're gonna need tubing, you're gonna need probes to be able to test the air inside of the confined space at different levels because of the behavior of gases. You have to have calibration gas. You have to make sure that the calibration gas is not expired. It does have a shelf life. You have to understand the function of your equipment. You have to understand the equipment limitations. What is the response time of the equipment? Remember, if you're using tubing in a probe down inside 6 feet or 8 feet in a confined space, it's going to take time for that gas to come through the pump and the monitor all the way to the monitor, enter the sensors and the actual equipment to give you an accurate reading. So make sure that you know the limitations and the response time of your monitors. Your sensors life. The sensors on these pieces of equipment have a shelf life. So you need to make sure that when the equipment is doing the self-testing, during that self-testing, all the sensors are working properly. Your battery life is very important. Always use a fully charged monitor. And also, you also have to check the filters that protect those sensors in your equipment. Inspect those and make sure they're in good shape. Another important consideration is the alarm settings on your monitors. You have to verify every time you're going to use them that the alarm settings are properly set according to manufacturer instructions and specification. You have to verify the visual and loud audible alarms of these pieces of equipment, that when they detect something out of the settings that you have for detection, they're going to sound the alarm and you need to exit the space immediately. So I cannot stress this enough. Calibrate, and calibrate your equipment. If your equipment is not properly calibrated, you're not going to have accurate and reliable readings. And remember, workers are entering this space. Your readings have to be accurate. There's no exception. You need to do your regular calibration, especially if the monitor has been sitting there for a while. That needs to be calibrated. I would calibrate every time you're going to use it, every day. And also, equipment also requires, depending on the manufacturer, requires that manufacturer calibration either annually or biannually. You have to check those requirements in your pieces of equipment and send those for calibration to the manufacturer so it's in good shape. Also, you have to bump test your instruments according to the instructions. Using the calibration gas, you can just bump test it and make sure that all the alarms are sounding and everything is working. So, and make sure that your alarm settings are correct. So just wanted to mention that some alarm settings are set according to the exposure limits of the gases, the permissible exposure limits, like for hydrogen sulfide or carbon monoxide. That doesn't mean that you have to use only those settings. You can use a more protective, more restrictive settings and lower permissible exposure limits as to be more effective. I want to mention something that some of the most common mistakes when you do air monitoring. One of them is assuming that toxic gases are only limited to hydrogen sulfide and carbon monoxide, because that's what my monitor says. Also, the monitoring equipment would expire calibration. Keep good records of the calibration on your equipment. When is the next calibration due? Your manufacturer's calibration, and when is your regular calibration due? Also, not bump testing the equipment and make sure that everything is working. A piece of equipment can fail anytime. So especially if it's been sitting there for a while, after you calibrate, before you start using it in the confined space, bump test it. Now, failure to know the instrument response. Like we mentioned before, the time that it's going to take for that air that is being suctioned by the tubing and the probe all the way to the sensors, and for the equipment to have sufficient time to give you an accurate reading. So, like we mentioned, is failure to know the instrument specifications and limitations. Failure to test different levels inside of the space. Remember the behavioral gases, some sink, others float, and so on. And failure to test prior to and through entry. And of course, failure to perform continuous monitoring. Also, I wanted to mention some common mistakes in confined space entry. And the big one is failure to recognize it is a confined space. Failure to have an effective confined space entry program. Lack of effective worker training. Failure to identify the hazards inside the confined space. Underestimating the dangers and potentials of those hazards. Failure to test the atmosphere inside the space. Failure to perform continuous monitoring after the initial testing. Forgetting a hazard may develop while working inside of the space. It's caused by the type of work you're doing, or it may be considerations also with adjacent areas and gases or contaminants migrating to the space where you're working at. And failure to make rescue preparations. OSHA has a very good publication protecting construction workers in confined space. It's the OSHA 3825. There is the website address where you can download this publication. It has a very, very good information. I invite you to read that publication as well. And also, OSHA has a very good website for confined spaces in construction. And I invite you to look at the frequently asked questions section. Very good information, a lot of good questions and a lot of good answers that clarify the applications of confined space. So with this, I conclude my presentation. So now I would like to pass the presentation to Nicholas for he'll take the audience questions.
Thank you, Louis. And now we'll take questions from our audience. Our first question, are we going to get a certificate showing that we attended today's presentation? And I'll answer that. Certificates of attendance will not be provided for today's webinar on confined space and construction. Our next question, how do you reclassify a permit required space to a non-permit required space?
I'll take that one. If the permit required space was designated is because of some sort of hazards, a condition existed. If the space itself no longer has that hazard or no longer possesses any hazards to the entrance, then that space can be classified as a non-permit required space.
Thank you, Gabe. Our next question, related to confined spaces, would it be better to train all workers in confined space rescue?
You don't have to train all of them in confined and the rescue. However, that would be a very good practice if you can afford it or if you have the capabilities to do that. However, if you are going to be using the system, the 911 system, the 911 system, okay, you need to address that in the plans and take appropriate measures to identify them, let them know what you're going to be doing, even invite them over so they can have they can train in that area. If you're too far away from that system to work, then this is what we talked about, having and developing your own rescue team, and that team has to be specifically designed for rescue operations, and they need to have the necessary and proper equipment and train accordingly and receive the certification that they need. But going back to the question, if you want to train all your workers in confined space rescue, and if you have the ability and the power to do that, that'll be great. But make sure that the rescue personnel also have the CPR and first aid training.
Thank you. Our next question, how often should air monitoring equipment be calibrated?
I'll take that one. You have to calibrate according to manufacturer specifications. Read the equipment manual and see what the manufacturer is recommending. In general, you have to also consider the conditions in which you're using your air monitoring equipment. I would recommend that you calibrate every time you're going to use the equipment. If you're going to do confined space entry tomorrow, make sure that you calibrate before you do that.
Thank you, Luis. Our next question, what areas at construction sites are considered confined spaces but not commonly identified as such?
I think that was the poll question that I had, and it's the most common site by far would be trenching and excavations. They have the requirements needed to be classified as a confined space. However, they have their own subpart in the regulation, and they're covered under that subpart, not the confined space program.
Thank you. Our next question, does OSHA have any information available for a small company to write a confined space program?
I'll take that. Yes, OSHA does have a great amount of information available at their site. However, we also have Safety Rider, and Safety Rider, once again, can allow you to put together a safety plan and incorporate the areas that are needed for you to become compliant. In addition to, as Dr. Ward mentioned about our services, we can also help you put together a safety plan and guide you in the right direction and provide you with the necessary training items that needed to become proficient at this.
Also,
If I could also,
go ahead.
if I can also also add to that, Lois, and I'm thinking you're probably going to say the same thing. There's an OSHA guide out there as well that talks about protecting construction workers in confined space. It's a small entity compliance guide. There's an OSHA document. I want to say it's OSHA 3825. That gives you very, very concise documentation of how you establish and execute a confined space program for those small construction entities. And you can elaborate more, Lois, if that's what you're going to say.
Yeah, I was going to mention the OSHA 3825, protecting construction workers in confined space. It actually even has in Appendix B, page 44, has a sample entry permit. So read that publication. That gives you a lot of information on how to prepare and implement a confined space program. And like Gabe mentioned, you can also give us a call, and we'll help you navigate our safety rider and help you put together a confined space program.
Thank you all. Our next question. Can you talk about the hazards associated with working in an oxygen-enriched atmosphere when ventilation reduces the UFL to the LEL?
Yeah, what happens is that when you do your air monitoring and you find that the LEL is over 10%, in most cases you're going to be using mechanical forced ventilation in order to bring the values back to what you want. And also, like we mentioned before, you have to pay attention to the oxygen concentration. So that can be also an indication that what's in the air and between the value of the oxygen and the LEL, you're going to determine that your atmosphere is safe to enter. Well, the hazards when you have these conditions is like we mentioned before. The flammability of anything that you're doing inside of the space is going to increase. So things can catch fire or explode faster, quicker, when you're exceeding the lower explosive or lower flammable limit inside of the confined space.
Our next question. Where can I find a risk hazard assessment checklist for use on the construction site to complete a risk assessment of a confined space on the construction site?
That's a good question right now. As for a checklist, I have to just check to see if I do have a self-assessment or a checklist for confined space. I know I have several of them. I don't recall having one specifically for a confined space, but I'm sure I can find one. Do you mind maybe taking the information from the person who asked this, and we can get back with them?
Sure.
Yeah, I think I'm intrigued by that question as well. We've got what's called the permit conditions, knowing what to look for in a confined space. That will give you an assessment of the risk. You're assessing the risk in a confined space, as Lois just mentioned. But I'm not sure if there is, and again, we just need to get some clarification, if there's a risk hazard assessment checklist for the construction site as it relates specifically for confined space. So that we just need some more clarification.
Our next question. What is the difference between bump test and field test?
Bump test is when you use the calibration gas to create a reaction on your running monitor to see if the alarms, the audible and the visual alarms, are properly working. Therefore, the sensors are actually in good condition. Field test, it's a more generic term. I'm not sure, because when you do the bump test, you want to do the bump test in an atmosphere. It most likely is not going to be inside near the entrance of the confined space, because you want fresh air in order to bump test your equipment properly. So you can do bump tests in the field, but make sure that you're not doing it like close to the entrance of the confined space, because that air might be already contaminated, and then your bump test might not be as effective.
Thank you, Louis. And we just have a few more questions. Our next question, can you provide an example of reclassification of PRCP to a non-PRCP?
Can you repeat the question, Nick?
Yeah.
The question is, can you provide an example of reclassification of PRCP to a non-PRCP?
So this follows
To a non-permit required.
Yeah, that's exactly what it is, Gabe.
Yep. And I'll try to tackle this one. So they're trying to go from a permit required to a non-permit required. I would say you go into a manhole and you test it out, and you have gathered evidence that this site is contaminated. It has hazardous atmosphere, so you classify this as a permit required confined space. But let's say down the road somebody opens up an airway and flushes all that out, and you come back and you test that manhole again, and there's no evidence of that hazard anymore. Okay, so that's what happens when you have a permit required space, and then all of a sudden there's no more hazards in there, and then you transfer that over to a non-permit required, or just a confined space, period.
Thank you, Gabe. Our next question, is it required to have on-site rescue service for confined space entry? I was told not to rely on 911 as a rescue means.
Well, 911 that's a great question. Just because we call 911 doesn't mean that they're going to send somebody there that knows what's going on. That's why it's critical for employers to make contact ahead of time with their EMS services and plan this ahead of time. Let them know what you're going to be working on, what conditions you're going to be working on, so they can prepare for it, and they can have maybe a specific response vehicle on standby. So if that doesn't work, or they don't have one nearby, then it's up to the controlling entity to go ahead and put in a self-rescue team, where these people have to be, once again, completely trained in rescue operations, have first aid and CPR trained, and so forth, and have them available at all times. And well, the nice thing about having your own team is, once again, they're going to be very, very familiar with the site that you're in. If you're calling 911, once again, you never know who's going to show up, and do they have the capability or even the equipment to provide rescue.
Thank you.
Yeah, just to add to that, I think Gabe is spot on. And the answer is really depends. You know, so there is a nice checklist in the on that same guide we talked about that you can use to perform an evaluation on that off-site team. So if you're not comfortable with the 911, there's an analysis you can perform to see if that other rescue team can perform the activity based on competencies, based on proficiency, based on time to rescue. right? How long would it take for that rescue service to get to your site? How often are you performing these confined space entries? So all these things are taken into consideration before deciding whether you want an on-site rescue team or an off-site rescue team. And if you're going to go with an off-site rescue team, is 911 the answer? Fire department? Or a company that's devoted to simply performing these type of rescues? And that's when you'll do perform that that inspection or that evaluation or those questions on whether this is the company for you.
Thank you, Dr. Warwick. And our next question, are spaces above a suspended building ceiling considered a confined space?
Once again, let's go back to the definition. Any space can be classified as a confined space as long as it meets that criteria that they're really not designed to be worked in, and limited entry and so forth. The biggest difference between a permit required confined space and just a regular confined space is a permit required has some sort of hazardous atmosphere or dangers in it.
So to answer that question, yes, it could be a permit. It could be a confined space, but the next question is it a permit required? Confined space is the true question. So yes to the first answer, the first question. It could be. No, it's probably not a permit required confined space, depending on what the hazard is, as Gabe mentioned.
Yeah, and then I would like to add that in order to be a permit required confined space, there has to be a worker exposure to something, physical, safety, health, air, whatever hazard in that space that will cause impairment of ability to self-rescue. If something can happen in that area in which maybe the worker gets impaired, gets unconscious or whatever the case is, and then it's not able to self-rescue from that space, then it is a permit required.
Thank you all. And our last question, can you describe how organic matter can change the atmosphere in a space?
Yeah, but the composition of organic matter is gonna create gases. It's gonna create, depending on what the organic matter is. For example, can create methane or hydrogen sulfide. It depends, but the composition of organic matter is gonna gas off potential hazardous toxic gases. That, like we indicated, will be displacing the oxygen, and some of them might create asphyxiation because of the lack of oxygen.
And it looks like we got one more question in here that we have time for. In a trench, could a confined space be created?
Well, yeah, a trench is technically a confined space. However, as I mentioned before, it goes into the regulation under trenching. Subpart P, I think it was.
Thank you. And that concludes the question and answer portion of our presentation. I'll now hand this back over to Thalia Barber.
Thank you, Nick. Just taking a look at the chat, I do see a couple more questions. I think we have time for one or two additional questions. If you do use an outside rescue source and they get called to another call, do you have to pull your people out of that confined space?
I'll take that on, and Gabe, you could chime in as well. You know, one of the responsibility that outside contractor has with the employee is to alert the employer when they're unable to perform any type of rescue. So this shouldn't come as a surprise. That's an agreement, a memorandum of understanding you have with that outside employer. There's actually one of the checklist item you will also use to evaluate that offsite rescue company. So if it does happen, well, obviously you won't use that company again. You have a responsibility at that point to actually remove the entrant from inside the confined space. Right. So if they get called to another site, they need to alert you that they are unable to perform the rescue operation. Then you have a responsibility as a supervisor of that entry to alert the entrance to get out, to vacate the space, especially if you don't have your own rescue team. And in most cases, you wouldn't have both a rescue team internally and an outside rescue service. Gabe, you can add to that if you want to add to it.
Well, no, I don't have anything to add. Actually, that was dead on, and that's what we need to do. Is once rescue operations is not available anymore, then you are putting those employees in danger, and you must take them out of there.
There's a question here, Gabe, that talked about OSHA said a trench is not a confined space. Can someone check on that?
Well, I remember the question is by definition.
Right.
It's not. It's not because it's covered under subpart P, 1926-650 excavations. So technically, an excavation is not, and that's one of the reasons I put that at the beginning of the to kind of get everybody going. But an excavation is by definition, it is because it has all the necessary requirements of confined space, and you'll find it everywhere. However, it is not covered under the confined space program because it's covered under subpart P, 650.
Yeah, I think that the thing to keep in mind, these vertical standards such as trenching and excavation will take precedence over these horizontal type of standards such as confined space. So almost like the telecommunication standard will take precedent over those manholes that workers are going into because they have their own confined space. Definition as well is almost similar to the trenching and excavation. It really depends on which standard they are looking at.
Thank you. Thank you, Nick, and a special thanks to our presenters and all of our attendees for your participation in today's webinar on confined space and construction. If you have not yet completed the survey, can you please take a moment to do so now? The survey can be found in the questions panel. I will leave the presenter's contact information up for a little while so that you may jot that down should you have any additional questions that were not addressed today. This concludes today's presentation. Thank you.